So what we're going to do today is we're going to look at section 8. And this is solving inequalities with one variable. And let's look at that very first example on page 257. Basically, this is what you have. F of x equals x plus 3, and then x squared plus 1, and then x minus 4 squared. And so the question for us is, where is this 0? Where is this positive? And where is this negative? And so what we're going to do for the zeros is we're just going to look at each piece right here and set each piece equal to 0. So x plus 3 equals 0. X squared plus 1 equals 0. X minus 4 equals 0. And you work all of those guys out. So where do you get 0? When x is negative 3 and 4. Right here, this guy will never ever happen, because you're going to end up with x squared equals negative 1, and we're not worried about imaginaries. And then we're going to create a sign chart with this information. So we're going to take our factors, x plus 3, x squared plus 1, and x minus 4 squared, and we're going to set up a sign chart to examine what's going on. And we're going to separate the parts of our sign chart by using our zeros, negative 3 and 4. So what we're going to do is we're going to pick a number from each section of our chart and plug it into the linear pieces. And when you do that, you're going to get negative 4 plus 3. Now, I don't care what the answer is, but I do care if the answer is positive or negative, and this answer is negative. We're going to check negative 4 squared plus 3. And is that answer positive or negative? And the answer is positive. And then we're going to check negative 4 minus 4 squared. What does that equal? And it also is positive. And so basically you've got a negative number times a positive number times a positive number, which makes a negative number. So we're less than 0 from negative infinity to negative 3. Now check 0. So 0 plus 3. Again, I'm not concerned with what the exact answer is, but that is a positive answer. 0 squared plus 1. What is that? He's also positive. And 0 minus 4 squared, that guy is also positive. So when we go for numbers that are positive, we've got a positive number times a positive number times a positive number, and that is positive. So where are we positive? From negative 3 to 4. And then check the last guy. So we're going to do 5 plus 3, positive or negative. We're going to do 5 squared plus 1, positive or negative. We're going to do 5 minus 4 squared, positive or negative. And these guys are all positive. So where is this graph positive? From 4 to 5. Remember, it's 0 at 4, so we cannot include the 4. Okay, look at example 2 on page 259. And they give us 2x cubed minus 7x squared minus 10x plus 24. And that is greater than 0. And they tell us to do this analytically. In other words, we're going to have to find our zeros without a graphing calculator. So you can do your rational root theorem, which is going to be pretty hefty because you got 24 on the top and 2 on the bottom. So you're looking at plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4, plus and minus 6, plus and minus 12, plus or minus 24, plus or minus 8. Is that everything? 1 and 24, 2 and 12, 3 and 8, 4 and 6. And on the bottom is plus or minus 2. So I don't want to have to check all of those different guys, but I know I get a broad range of numbers. I'm going to check for 4 through synthetic division. So 2, negative 7, negative 10, and 24. It's 8, 1, 4, negative 6, 24. Perfect. So what I've got is 2x squared minus x minus 6. And I can check for another rational root, or I can look and see if this will factor. And this guy actually factors. So what have I got? I've got 2x here and x here. And then I've got minus 3 here and plus 2 here. Does that work? So 2 is 4, 3. So I need, that should be plus 1. That works. Negative 6 works. Okay, so this is good. And then since 4 is a 0, that means that x minus 4 is also a factor. So here are my 3 factors, and I want to know where this function is greater than 0. So make the sign chart again, and we'll use 2x minus 3, x plus 2, and x minus 4. And I want to know where my zeros are. So your zeros here, 2x minus 3 equals 0. So x equals 3 halves. X plus 2 equals 0, so x equals negative 2. And x minus 4 equals 0, so x equals 4. And list these guys off in order from smallest to largest. Negative 2, 3 halves, and 4. And check a number from each spot. Now you don't have to actually do the math. We just want to know what is the sign going to be at these different places. So when I put a negative number in here, I'm going to get negative. When I put 0 in, I'm going to get negative. When I put 2 in, I get positive, and when I put a 5 in, I get a positive number. I'm not concerned with the actual number, just the sign of the number. On the second row, when I put a negative 3 in, I get negative. When I put 0 in, I get positive. When I put 2 in, I get positive. When I put 5 in, I get positive. Then the last row, I put negative 3 in, I get negative. I put 0 in, I get negative. I put 2 in, I get negative. I put 5 in, I get positive. And so multiply going down. Negative times negative times negative is a negative. Negative times a positive times a negative is positive. Positive times negative is negative. And then the last guy, all positives. So the question for us is, where are we greater than 0 but not equal to? And the answer, f of x is greater than 0 from negative 2 to 3 halves together with 4 to infinity. Alright, so let's look at how to solve one of these guys on your graphing calculator. This will be example 3 from page 259. and it starts off with x cubed minus 6x squared is less than or equal to 2 minus 8x. And one of the easiest ways to do that is to use your graphing calculator, but clean it up a little bit by moving these two guys over to the left. That gives us x cubed minus 6x squared plus 8x minus 2 is less than or equal to 0. And then when you put that on your calculator, you'll get a graph that looks like this. And the things that we're interested in are the places where we cross the x-axis. Those are the places that we're interested in. So use your calculator to find those zeros. And we're going to discover that those zeros occur at 0.32, 1.46, and 4.21. And we want to know where we are less than 0. In other words, where are we under the x-axis? And so for this particular guy, from negative infinity to 0.32, and then from 1.46 to 4.21. And that would be your answer. And that's all there is to it. Alright, let's look at another function type now. Let's look at a rational function. This is going to be example 5 on page 260. And we'll let our function look like this. 2x plus 1 divided by x plus 3 times x minus 1. And what we're going to do is we're still just going to look at the zeros of each piece. We want to know where 2x plus 1 is 0. We want to know where x plus 3 is 0. We want to know where x minus 1 is 0. And this is going to be at negative 1/2. This is going to be at negative 3. And this is going to be at 1. And then we're just going to make a sign chart with those guys. So we want to have our 3 zeros here. And we know that at negative 3 and 1 we're undefined, okay? But we can still list them off. Here's negative 3, here's negative 1/2, here's 1. And I know I am undefined on these points. There's no way I can get an answer that's true. But we can still use those points to determine where we will be positive or negative. And now we just set it up exactly like we've done several times already. So a number less than negative 3 gives us a negative, gives us a negative, gives us a negative. A number between negative 3 and negative 1/2 will give us a negative, and then a negative, and a negative. This guy should be positive. And then 0 in here will give us, and then a 2. So we've got a positive, negative, positive. So if I'm answering the question, where is this function positive? It's going to be from negative 3 to 1/2. Together with 1 to infinity. And if I'm asked where this guy is negative, it's going to be from negative infinity to negative 3, together with negative 1/2 to 1. Okay, what if you end up with a rational expression with some addition going on? So this is going to be like example 6. 5 over x plus 3 plus 3 over x minus 1 less than 0. Basically what we need to do is combine things down to get a common denominator on the bottom. and add the tops. So this side needs x plus 3. This side needs x minus 1. And what I end up with is 5x minus 5 plus 3x minus 9 on the top. And on the bottom, I'm left with, don't FOIL it out, x minus 1 times x plus 3. And I want to know where that's less than 0. So clean the top up one more time. 8x plus 4 over x minus 1 times x plus 3. So find out where we equal 0. So I want 8x plus 4 to equal 0, and x minus 1 equals 0, and x plus 3 equals 0. So x is going to be a negative half here, a 1 here, and negative 3 here. And this should look really familiar because it's almost identical. It is identical to the problem we just solved. So when I make my sign chart, it'll look like this. Negative 3, negative 1/2, and 1. And then you just substitute your things in, your numbers. A number less than 3 here, number less than 3 here, number less than 3 here, and it's negative. Substitute in a number between negative 3 and a negative 1/2, like a negative 1. Substitute in 0. And substitute in a number larger than 1, like 2. And so, where are we? Positive? We're positive from negative 3 to negative 1/2, together with 1 to infinity. And we're negative. Whoa. We're negative from negative infinity to negative 3, together with negative 1/2 to 1. Alright, so now what we're going to do, let's look at an inequality with something nasty in it, like a square root. And what do we do now? Well, we still need to know what the zeros are. Those are super important. That doesn't change. But here's what we're looking at. We've got these two guys. So basically, I need to know where x minus 3 equals 0 and where x plus 1 equals 0. I still need to know those things. Keeping in mind that I can choose no numbers less than whatever I get right here. So x equals negative 1, x equals 3. So when I make my sign chart, I've got the square root of x plus 1 and x minus 3. So I'd use negative 1 and 3 for my zeros. But we're going to be undefined here. The reason is because any number that we put in right here, negative 2 plus 1, that's a negative 1. You cannot take the square root of this. You can't do it. So anything in this column is undefined. We can go ahead, though, and check zeros. So when I put a 0 in, because that's between negative 1 and 3, when I put a 0 in, I get a positive and a negative. And when I put a 4 in, I get a positive and a positive. So where is this guy positive from 3 to infinity. Where is it negative? From negative 1 to 3. Where is it undefined? From negative infinity to negative 1.